circumference of circles. Circumference of circles. We've taken care of area of straight side figures, perimeter of straight side figures, blah, blah, blah. Now let's go to the funky figure circles. Circumference. Now there's a few things we need to know about circles before we even try to tackle circumference. So first, what's the definition of a circle? And you can't say it's a round thing, and you can't use the word circle in the definition. All right, Ron.
It's a spherical figure.
Spherical. That is 3D. Okay, all right, so 3D. Brother Hill?
It is completely round with no angles and no straight lines.
Well, that's pretty good. But I said you can't say it's a round thing.
It's a 2D sphere.
2D sphere. No, because the sphere is 3D. That's pretty good, though. How about we keep going? You ready now?
A shape with no sides.
A shape with no sides. Well, that could be a lot of things. That could be an amoeba-looking thing. But that's a good try. So you picture a circle in your brain, right? You picture a circle in your brain, but then when you try to explain what it is, it gets kind of hard, doesn't it? Well, here's the technical definition of a circle. Ready? All the points that are equal distance from a center, bless you,
Thank you.
point. All the points that are equal distance from a center point. Now that may not help you. I pictured it in the race real good from the first period, but I'm gonna put me a point right there. There you go. Mark your point. Now go out a certain distance from there and put a dot, a point. Go out that same distance, put a point. Put another one, and 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 another one, another, and you just keep putting points. The same distance from that center point. You just keep putting more points. And sooner or later, those points run together. Well, ask him which one he wants. Just point at Hayden. Say Hayden. All right? And sooner or later, they run together. And what happens?
Just makes a circle.
You have what looks like a solid curve going around that center point. When in actuality, it's a whole bunch of thousands and thousands and thousands of tiny dots. Now that's the technical definition of a circle. We just picture it as this right here and go with it. All right? I'm just being technical with you. When you go to geometry class in high school, you will define what a circle is, and you will see that it's points that are equidistant from a center point. That is its official definition. So that's what a circle is. Can we go on?
Yeah.
Okay, here we go. Now, the parts of a circle. Parts of a circle. Let's draw one. Draw one. Ooh, that's a pretty good one, freehand. Parts of a circle. First one is a radius. How do we define what a radius is? Some of you know. I can go to the back row, Parker.
Isn't it the distance from the center to the edge?
I like that. The radius, a line from the center point to the edge. 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 So, from point right there, how do we abbreviate it? Just plain old R. Plain old R. That's a radius. Now what's the other thing?
Diameter.
Diameter. Well, how are we going to define the diameter? Using the same kind of words up here. A
Line.
line
Line from the
that
Goes through the hole.
goes
Through the line.
from
one edge to the other.
edge to edge through. Now I spelled through T-H-R-U because it's my notes. I know that's not the official way to do through, but I shortened it, T-H-R-U. Edge to edge through the what, y'all?
Center.
Through the center. You will learn there are some other lines that go edge to edge that don't pass through the center, and they're called something else, like secants and chords and things like that. But that's in geometry in high school. So we're dealing with a line that goes across like that right there, through the center point, from edge to edge. Now how do we abbreviate it?
D.
Plain old small case d. Small case d. So this right here is d. Now, can someone tell me the relationship between R and D? I'm going to go with Mike.
Diameter is half the radius.
Think of what you said there. Maybe you want to change.
Radius half the diameter.
There you go. Thank you, Maddie. You had it backwards there. The radius is half of the diameter. So in other words, a diameter is really made of 2 radii, correct? 2 radii. So you are correct, Matt, now. It takes 2 radii to make a full diameter. Or a radius, is half of the diameter. And that's the key in a lot of our thinking today. You know what we're doing. Now, we've got a little bit of information about circles now. We can now jump on to circumference. So now let's define circumference. The
Area.
no, I can't use the word perimeter because that's for straight-sided figures. I like that word. Who was that behind me? Good, way to help out. The distance around a circle. The distance around a straight-sided figure was our definition of a perimeter. Technically, it's the perimeter for a circle, but we can't use the word perimeter because that's for straight-sided figures. And our formula that mathematicians came up with for perimeter is add all the sides. Well, if I'm going to go distance around a circle, can I add up the sides? There's no sides to add. So I can't call it perimeter, because perimeter means add up all the sides. So I got to have a different way of doing it. So I'm going to measure around. I'm going to measure around and find the circumference of this Cuisenaire learning material lid, because it's circular, isn't it? So I put my measuring device. I'm finding circumference. I'm measuring, aren't I? The distance around it. So I'm going all the way around there. 27. 27 inches. Circumference. 27 inches. Woo! All right. Now that's one that's three-dimensional, that I can touch and feel and throw like a frisbee, you know? Ah, you thought I was going to throw it, didn't you? You were gonna catch it, weren't you? Right. Good job. Okay, now I want to do this circle right here. I want the circumference of this thing.
Why would you do that?
Well, I need to find the distance around the circle.
You can't do that.
Need help?
You can't.
Matt, thank you. Matt goes, you need help? Well,
You can't.
you see what I'm talking about?
You can't.
Can I actually take a measuring device and measure every circumference?
No, because it's not. It's 2D, not 3D.
So thank goodness
There's a formula.
mathematicians discovered the formula. And so now let's just use the formula and quit worrying about trying to measure stuff when it's too hard to measure. Because I sure can't use a straight measuring device to do it, because it's a curve. And I even thought I was smarty britches and got a nice flexible measuring device. And it still didn't work. So thank goodness we got formulas. Mathematicians discovered. So our formula for circumference. You ready for this? C equals 2 times. Now this is what they came up with. There's a 2 and there's a times. Then there's a funky symbol. 2 straight lines with a snake on top of it. And then times R. If you look on your chart that's on your desk for circumference, you will see that formula. Then there's a 4. And another one. 2. Is there a 2? Nope. No more 2s. No, on this one it's just funky symbol times D. All right. Looking at that. Looking at that. What's the funky figure? Or the funky symbol? What's the funky symbol? It's down at the bottom of your chart.
Pi.
Pi. Pi. It's a Greek letter. Goes with alpha, beta, gamma, pi, delta. Those are other letters from the Greek alphabet. Mathematicians picked this one. I don't know why. And after we get through with our lesson today, I'll tell you some more stuff about pi, but let's get this done because we're filming, right? All right. According to our chart, this symbol, pi, 2 straight lines with a snake on top, means something. What does it mean? It means the number 3.14. 3.14. 3 and 14 hundredths. And I'll show you something about pi in a little while. So, for this symbol, I can use 3 and 14 hundredths, or 3.14. So I'm going to write it in my formula right there. So when I look at it, I know when I need to use that, I'm going to use the number 3.14. We okay with that? How about all right with that? All righty. Cool, Daddy. Cool, Daddy Squid. Now, if we're told to...
It's time to
Kill it.